All right, so let's graph some functions given the equation. And it gives us this function. This is this is a exponential equation because the x is the variable and it's also the exponent. Okay, and let's look at this thing that we got going on. Our a value here is negative, so we know it's going to be on below the x-axis, so they kind of set us up already there. And then the b value, this b value, is going to be greater than 1, so we know it's going to grow in the negative direction. All right, so it's going to start negative and it's going to grow even more negative. Okay, because this, if we had it just without a negative sign, it would grow, it would start at 4 and then grow exponentially from there, but it's negative, so it's going to start at -4 and grow exponentially. Right, so since a is negative, we know, and b is greater than 1, we know the function is going to be, it's going to be going downward. It's going to be down. So the left-hand behavior, so it means if it's going down this way, it should be approaching 0. Okay, and then the y-intercept, of course, is the a is the -4. Right, so let's see where I got all this stuff from. Okay, just by looking at the equation. After we graph it, it should become more intuitive. Okay, so if I plug in, let's say x equals 1 or 0, x equals 0, and that's therefore the y-intercept. Right, so if this equals 0, then it's going to be something raised to the 0, which is just 1. Right, because anything raised to the 0th, you know, is 1 from the laws of exponents. So it's going to be -4 times 1, which is -4. So when x is 0, y is -4. Okay, so then we know that this part of this is greater than 1. Right, so when I put a number in there, we'll say 1. Right, it's going to be 1.65 to the 1.65 or 65, right, times -4. So it's going to be -4 times 1.65, which is like, let me get a calculator. So when x equals 1, it's going to be whatever this is to the first, which is whatever that is. So it's going to be 1 plus 0.65 plus 0.65, which is 1.65 raised to the first, and multiplied by -4. So that's going to be y equals -6.6. So it's going to be way down here when y is 1. Yeah, it's -6, almost -7, like right there. Okay, and then when y is 2, so sorry, when x is 2. Right, this is going to be 1.65 raised to the second, which is 2.275, multiplied by 4 negative. It's going to be like -10. So when it's 2, it's going to be like way down here at like -10. It's off scale. Okay, so it's going down super fast on this side of the y-intercept. Okay, so what about if it is a -1? So when x is -1, let's change the color to like dark green. So when x is -1, they look like the same green. That's okay. When x is -1, all right, let's do 1.65 raised to the 1 negative. It's this thing, which is 20/33. Right, I'm going to multiply that times -4, and it's like 2.4-ish. Right, so at -1, this is like -2.4-ish right there. Okay, how about when x is, let's go all the way down here to like -4. So when x equals -4, I have an intuition that's going to get closer and closer to 0. So let's do 1.65 raised to the -4, or the 1/4. Right, and it's going to be like 1.3, so 0.165 raised to the 4 negative, which is, okay, and then whoops, 1.65 raised to the negative 4, okay, multiply that by 4 negative, that's going to be 0.539. Double check that one more time. All right, so 1.65 raised to the 4 negative equals times 4 equals just over 0.5. It's like I had an operator error calculation. Now that's what happens when it's negative 6. So 1.65 raised to the 6 negative, and it's going to be that number multiplied by 6, or by 4, excuse me, multiplied by negative 4, and it's going to be just under 0.2, so it's going to be like right here. Right, so you can see, what about when it's negative 2? Let's put a little dot right there. When x equals negative 2, well, it's going to be 1.65 raised to the 2 negative, and multiply that. Whoops, that was the wrong button. Okay, 1.65 raised to the 2 negative equals, multiply that by negative 4, and it's like 1.5 about. It's like right there-ish. All right, so you can see that kind of completes our exponential decline. So there's that, my big fat line like that, right? So as x approaches negative infinity, right, as x approaches negative infinity, y approaches 0. And then as x approaches positive infinity, y approaches positive infinity, or negative infinity. Okay, so that, let's have a pretty good understanding of what we got going on here. So here's this 5 to the times 2/3 my growth factor, so it's going to grow by like 66% every time. And I even gave us cool values to plop in here. Right, so I know that this is going to be a decay because this is going to get smaller and smaller and smaller every time I make x bigger and bigger and bigger. So as x goes up, this term becomes smaller, and it's going to multiply by 5. Right, and if 5 is my starting point at 0, right, it doesn't even give me that. Right, actually it does. I know it's going to be 5. Why is it going to be 5? Right, at negative 2, right, what is it when 2/3 raised to the negative 2? 2/3 raised to the 2 negative equals, and then multiply that by 5. Right, it's 11.25. Right, so this is 11 at negative 2. This is 11 and some change right there. Okay, and then at 1, it's going to be somewhere, but probably right here somewhere. So when 2/3 raised to the 1 negative equals 1.5, then multiply that by 5, it's going to be 7.5. 7.5. So 7.5 is like right there. Okay, and then that's at 1. So it's going to be 2/3 times 5. 5 times 2/3. It's going to be 3 1/3. So when it's 1, it's like 3 and a little bit more. Okay, and then at 2, so 2/3 raised to the 2nd power is 4/9 times 5 is 2 2/9, or like 2.22222 repeating. So when this is 2, it's going to be like just over 2. Right, so it's going to go infinitely in the negative direction for x, and then approach 0 closer and closer and closer in the positive x. Okay, so what was this? This was like 2.22 repeating. 2/3 times 5 was 3 1/3. 3 1/3. Okay, so that's what we got going on. So is this the growth or decay? This is a decay. Domain and range. This is, the domain is all real numbers. The range is anything greater than 1. That's where this exists. Or anything greater than 0, excuse me. Everything greater than 0. So all values of y such that y is greater than 0. Not equal to, because it'll never reach 0. But it's that. And this is going to be decreasing because it goes as x goes that way, y goes down. So this is decreasing. A constant percent or rate of change, right? This is going to be 2/3 or 66.67%. So it's going to get smaller by 66.67% every time. Okay, the left end behavior, so this way left is as x approaches negative infinity, y approaches infinity. That's the left end. The right end is x approaches positive infinity, y, oh, you can't see what I'm doing, y approaches 0. And then is it positive or negative? Well, it's positive. The whole thing's above the x-axis, so it's positive. All right, hope that helps with graphing these things. They're pretty easy to graph. Just plug in an x. They get real big and real small real quick.